Hello and welcome to my talk on integrating TTK into Inviwo. My name is Martin Falk and I'm with Linköping University, Sweden. I'm assuming that all of you are at least somewhat familiar with TTK, which leaves the question, what is Inviwo? Inviwo is a research-focused visualization framework developed by groups at Linköping University, Ulm University and KTH. It is a rapid prototyping tool for creating arbitrary visualizations using a combination of C++, Python, JavaScript and HTML. Initially, Inviwo was targeted only towards medical imaging, mostly relying on volume rendering techniques. But over the past couple years, the functionality has been steadily growing, and now Inviwo supports a wide variety of different visualization techniques, covering things like, for example, vector field visualization, molecular VIS, and since we now also have a TTK binding, topology-based methods as well. From a technical point of view, Inviwo has a pure C++ core, which provides the basic functionality for everything. On top of that, we have a modular plugin layer, providing us with the functionality of wrapping external libraries, like for example OpenGL, Python and OpenCL, but also to be able to easily extend Inviwo's functionality. As you can see here, for example, we have a vector field visualization module, which then depends on BaseGL and OpenGL, as well as brushing and linking. On top of this, we have then the application layer, basically the front end for the user. Inviwo is shipped with a network editor and a Python interface, but this layer then also allows you to easily create your own application on top of our framework. Since we have this plugin architecture, Inviwo supports a wide variety of different data formats. Let it be imaging data like DICOM, H5, TIFF stacks, or even RAW format. Then we have some mesh support via a SIMP, and at the moment we are also currently working on integrating the VTK data format. The underlying principle of Inviwo is a visualization pipeline, or as we call it, a processor network, which models a data flow graph. So in this example here, we have a volume source reading a file from disk, and then this data is propagated down through the network to this volume rendering processor before the result is shown in the canvas. Each of these boxes basically correspond to their own algorithm or function. We also call them processors, and each of these processes only depends on the inputs coming from above. So in a sense, this whole pipeline is basically a function. And hence, we can then also say that, or consider it as a stateless function. In practice, this is not entirely true because the outputs of each process are cached to avoid unnecessary recomputation. And then only when the data is changed or some parameters changed, then we trigger a recomputation of those parts in the network. In order to create such networks, you can use the network editor, as I have mentioned earlier, which is shipped with Inviwo. And the editor consists of the following parts. On the left-hand side, we have a list of all available processors, that is all the functions available to build a visualization pipeline. You can then drag and drop these into the central area to build your own processor network, and then the output is rendered in its own canvas. In order to adjust parameters of your processes, here for example we have selected the volume rendering. You can do this via the property list. For example, here we can then tweak the transfer function or also adjust the sampling rate and camera parameters. So much on the overview on Inviwo. Now let's get into how we actually integrated TTK into it. Small disclaimer here. we are only working with the core API of TTK, that is the C++ side, and thus we don't have a support for the VTK and ParaView plugins of TTK. In the beginning, we started out with the TTK C++ example, where we basically read a input geometry, apply some topology methods, and then output the resulting geometry. In practice, we have basically put the entire code of that example into one of these processors. The only thing pointing out here is that since we are dealing with data coming from Inviwo down the network, we have to convert our data into a TTK representation before we then can start computing, for example, the persistence curve, the persistence diagram, and the simplification. And then towards the end, we convert the TTK representation back into something Inviwo understands, so we can render it on the canvas. So for a starting point, this is quite good, but you don't want to repeat these TTK calls all over the place. So we decided to split up this functionality into multiple processors. As you can see here now in this example, we now have a processor responsible for the conversion, and then we have these individual steps like persistence diagram and the simplification before we convert the data back to Inviwo. On the code side, basically what was required there is that we have several conversion functions to convert data from Inviwo to TTK, and at the moment we support meshes and volumes, and then create the corresponding TTK triangulation out of it. In order to pass on the data to the next processors, we wrap the TTK data structures here, for example, the TTK triangulation in its own object, and then each processor can output that stuff and the next one can read it into. This principle allows us then also to easily extend it. Here we have added another conversion to a data frame, which allows us then, for example, when computing the persistence curve in TTK, that we then create these corresponding values and then use the plotting functionality available in Inviwo to create a persistence curve plot or a persistence diagram. Let's now have a look at how that looks in Inviwo. Here we have a volume source converted to a triangulation and then compute a more small complex, which we then render with points and lines. And now we go ahead and add a simplification processor by simply dragging it in. And those familiar with TTK might know that you need a persistence diagram in order to perform the simplification, so we add that one as well. And now we can adjust the threshold of the simplification and then look at the result interactively. In order to also show the result of the triangulation, we hook that up to our visualization as well. Since those lines are quite jagged, we took the liberty of creating another processor for refinement of those separatrices, which is basically using a spring system, drawing these separatrices along the gradients. So we pull in a processor computing the gradients of the input geometry, and then we can adjust the number of iterations in the spring system and thus get smoother separatrices for visualization purposes, that is. And of course, we can then go back and adjust the simplification threshold. Here's another example where we apply TTK. Here we compute also the more small complex, this time of a charge density field of iron oxide. As you can see here, we have lots of atoms and separatrices in there. This is then why we came up with this separatrix refiner. And then we can do things like here you see a sodium chloride charge density in combination with the refinement, resulting in a nice regular structure. To summarize our experiences with TTK, they have been quite positive. The first thing to point out is that TTK is quite modular, which proved to be quite helpful for us, because we could then start implementing individual functions, like for example the simplification or the persistence diagram, and then get started slowly instead of having to implement the entire interface at once. However, we learned quickly that TTK is mostly targeted towards VTK and ParaView, which in itself is quite a good thing. However, under the hood, you quickly stumble upon some strange things. Like, for example, the interface to some functions can therefore be quite extensive. In case of the more small function, you actually need to provide 15 different arrays as an input in order to call just one single function. And thus, it would be quite handy to actually have access to the internal data structures used by TTK, because there is only one or two objects around maintaining the entire state. If that had made you curious and you want to try out Inviwo yourself, I would recommend you visit the GitHub repository of Inviwo, or if you just want to check out the binaries, then you can find those on our webpage. Unfortunately, so far without the TTK support. If you want to have the TTK functionality and Inviwo, then you have to check out the modules repository, where you can then also find detailed instructions of what you need to do and set up in order to get both up and running. With this, I would like to wrap up and conclude my talk. Thank you for listening.